Hello, friends. Once again, you hello, welcome to another interesting episode of Mathematics class. But before then, I want to say a very special thank you and saying thanks a million for those of you who always watch my TikTok live. Always comes once in a while to like and comment on my posts. Some of you always add my videos to your favorite. To you all, I want to say thanks a million. I really do appreciate. So, welcome to another interesting mathematics class. Today, we're going to be considering addition in binary number system or simply addition in base 2. If you have been following my videos, you would have discovered that we actually started with definition of number base system. We proceeded over to mention the various forms of unique number base we have, and we also went further to do conversion in number base, converting from base 10 to base 2 and from base 2 back to base 10, and also expanding or converting from some other base to base 10. And so today we're going to focus more on the addition of base 2 or addition in binary number system. So here comes a question on the board for example 1, and the question says evaluate the following in base 2. Addition in base 2 is not like normal addition as in base 10, which you do see in everyday mathematics. It's entirely a different ballgame altogether. So pay attention while we resolve or evaluate this expression on the board. Here we are given 1011 plus 1101. Some teachers may tell you to put this at the very back of your mind or store this in your mind. I call that cramming. It's not really necessary. If you say, like, you have to cram that 0 plus 1, that 0 first, 0 plus 0 is equals to 0 in number base, 0 plus 1 is equals to 1, 1 plus 0 is equals to 1, and then you say 1 plus 1 is equals to 10. Yeah, so those of you who are novice in mathematics should be surprised. How come someone is saying that 1 plus 1 is 10? But that is what it is in mathematics, especially when it comes to addition in number base. 1 plus 1 is equal to 10. So some teachers may advise you to cram that, but it's not really necessary you cram that. From what we're going to see today, I'm going to apply a different strategy or different techniques altogether that you don't need to actually cram all these in your mind. So what do we do with this question on the board? If you say 1 plus 1 in base 2, in base 10, 1 plus 1 in base 10 will give you 2, which you and I know for sure. But when working in number base, when you say 1 plus 1 is 2, write it 2 here. Remember that the base you're dealing with is base 2. The base you're dealing with is base 2. So the technique I'm going to use is this. When you say 1 plus 1 is 2, then divide by the very base you're working with, which is 2 divided by the base. That will give you 1 remainder 0. And remember that in number base, the remainder is very, very essential. So on that note, I'm going to bring down the 0 here first. I will take this very 1 to the next line. So if I bring down the 1 to the next line, it's going to be 1 plus 1 again, then plus 0. It's still going to give me 2. Then divide by the base again, which is 2. It's going to give you 1 remainder 0 again. So you write down the 0 again, you carry the 1 over to the next line. So we're going to add the 1 again. So 1 plus 0 plus 1 gives you 2 again. 2 divided by the base again, it's going to give you 1 remainder 0 again. So you write down the 0, you carry the 1 over to the next line. Now watch this. 1 plus 1 plus 1 gives you 3. Gives you 3. So 3 divided by 2 gives you 1 remainder 1. On that note, we're going to write the remainder first. There's no other number here, so we're going to bring down the last one. You can as well do the cramming by saying, therefore, 1 plus 1 plus 1 is equals to 11. in number base. But applying this principle I just showed now, there's no point or needless cramming this in your mind. So that is how to do addition in number base. So I'm going to take another example for you to understand better and a little bit more complex. So what do we do when we have another more complex questions involving more numbers? So we're going to be dealing with example 2. And the question says, the question is saying you should evaluate the following in base 2. And the question is 1, 1, 1, 1, 1, which is up to 5. Then 0 and 1. You are adding 1, 1, 0, 1. Then 1 again. Then you have 0 and 1. You were asked to evaluate addition of number base. Remember, addition in number base is not like base 10. Though you can apply the principle of working in base 10 to do it, but you have to divide by the base. So what do? We're going to say, remember, you're working in base 2. So the same way, I said needless cramming this, but if you want to, if you know you won't forget after quite a long time, then you can cram it. But otherwise, it is needless cramming it so that any day, any time, well, after so many years, you can also recall how to add in number base. So what do? We say 1 plus 1 gives you 2 again. 2 divided by 2 gives you 1, remainder 0. Write down the 0 first. Bring the 1 over to the next line. 1 plus 0 plus 1 gives you 2 again. Divided by the base gives you 2. It's equal to 1, remainder 0. So you write down the 0, carry the 1 over to the next line. The same is applicable. 1 plus 0 gives you 2. Divided by 2 gives you 1 again, remainder 0. So you write down the 0 again, bring down the 1. So 1 plus 1 plus 1. 1 plus 1 plus 1 gives you 3. You say 3 divided by 2, which is the base, is equal to 1, remainder 1. Write down the 1. Even if you had chosen to cram this, to store this in your brain, it's going to be 11. Then you write it first, carry the 1 over to the next line. So what happens? Take the 1 over to the next line. You're going to have it here. It now becomes 1 plus 1 plus 1. That will give you 3. So 3 again divided by 2 gives you 1 again, remainder 1. So write down the 1, take the 1 over. So 1 here plus 1 here plus 0 gives you 2. So you now have 2 divided by the base again, which is 2, equals to 1, remainder 0. Write down the 0, carry the 1 over to the next line. You now have it here. So 1 plus 1 plus 1 gives you 11. But using this approach, 1 plus 1 plus 1 gives you 3. You divide by 2 gives you 1, remainder 1. That will give you write down the remainder first, then nothing is left here again. So you write down the 1. That is the answer. You write in base 2. So that is how to do addition in number base. But before the video comes to an end, I would love to take another example that will involve a decimal number. Another example that will involve a decimal number. Another example that will involve a decimal number. So when you have a binary number system or base 2, having a decimal point, what do you do? Is it really different from what you know? No. The same process, the same approach will be applicable. So now the question says that you should evaluate 1011.01. Then 0 point again. You have 1, 0, 1, 1. The difference between these and what we had done before is the difference of having a decimal point or a decimal marker. The right name for this the decimal marker, which is actually different from the decimal in number system. So the right name for a dot is a decimal marker in mathematics. So quickly, let's do this. 1 plus 0 gives you the same thing, which is 1. You can see that the 1 here is not up to the base. And whenever the value you get after adding is not up to the base, which is base 2, the answer automatically remains as 1. You can as well divide by the base. Even if you divide by the base, you will have the same thing, which is 1 divided by 2. It cannot. So it's going to be 0, remainder 1. So you write down this first, which is the same one here. Now you take the 0 over to the next line. It's still going to be the same thing, which is going to be 0 plus 1 gives you 1 again. So 1 again divided by 2, still the same thing of 0, remainder 1. Write down the 1 again, 0 go over. It's meaningless. So now you now have 1 here. 1 plus 1 gives you 2. 2 divided by 2 gives you 1, remainder 0. So you write down the 0, you carry the 1 over to the next line, which is 1 plus 1, bring the 1 here. 1 plus 1 gives you 2. 2 divided by 2 again gives you 1, remainder 0. So now you now have 0 here again. How about here? Take the 1 over to this again. So 1 plus 0 plus 1 gives you 2 again, divided by 2. That will give you 1, remainder 0 again. So you write down the 0, you carry the 1 over to the next line. So it comes here. So 1 plus 1 plus 1. By cramming, it is 11. But using this approach, it's going to be, using this approach on the board, is going to be 3. It's going to be 3 divided by 2, which give you 1, remainder 1. So you bring down the 1 here, then the remaining 1, no other number here. So you bring down the last 1. That is how to do addition in binary number system, be it values having a decimal marker or decimal point, or just a whole number like that. So thank you very much for being part of my today's class. Hopefully, I'm going to see you in next class, where we're going to be dealing with addition, subtraction in number base, and thereafter we'll proceed to addition in other number bases like base 16. What do you do? Or addition in octenary, or addition in base 5, whatever, so on and so forth. Thanks very much for being part of my class. Hopefully, I'm going to see you again. Thank you.